Okay, today's lesson is lesson 6 from Unit 6, and it corresponds with section 8.6, solving rational equations. So I always like to ask my students, what's the difference between an equation and an expression? Because what we have dealt with up to this point has been expressions, and I hope you answered that the difference is an equation has an equal sign. Okay, so that's the main difference between an expression and an equation. And when your problem starts off with an expression, it ends with an expression. If it starts off with an equation, it ends with an equation. And it should help you keep the two things separate. Okay, so as always, I like to define what we're doing. And so first off, we will tell you that a rational equation is one that contains at least one rational expression. Now, if your expression is a proportion, okay, and in case you don't remember, we're going to write that in parentheses, and that's basically when you have one ratio equal to another ratio, so equivalence of two ratios, and meaning there's no plus or minus on either term. Then you can solve it by cross multiplying. Okay, and that was kind of the thing that I warned you against doing in the last one, because when we dealt with expressions that have no equal sign, then you can't do the cross multiplication. Okay? Now, you don't have to do it. Sometimes it's easier, sometimes it's not. But otherwise, you can always solve it by multiplying. And what is easiest is to multiply both sides of the equation by the LCD, least common denominator, to clear the fractions from your equation. And then you'll see after we do that that it's just like equations that we solved before. So again, what we did on the last lesson, which was U6L6 or section 8.5, we multiplied everything by the form of 1. We multiplied it by 1, and this time, because we have an equation, I don't have to multiply by 1. I get to multiply by the LCD because I'm going to do it to both sides of my equation, and that's not going to change the value of my answers. Now, because we're doing that, we always have to remember to check our answers. And what are you looking for when you check your answers? You're looking for those restrictions that we've talked about the last couple of days in these sections, and that is anything that makes your denominators equal to 0. I'll write that up here so you have that. Denominator cannot be 0, so those values are thrown out. Okay, so let's go do one. We have what are the solutions of the rational equation. So here is one, and this happens to be a proportion. So yes, you can cross multiply, but I know that you don't want to multiply this binomial times that trinomial. Okay, but sometimes they're not so messy. But since it is, we're going to go ahead and multiply both sides by the LCD. Actually, I'll write it like this. So this is one side. I'm used to doing that because there's a plus in there. But what is my LCD? Well, that's x plus 2 and that's x plus 2. So the only denominator I have is x plus 2. So I'm going to multiply it by x plus 2. And when I do that, this denominator cancels with that, leaving me with just x minus 1 on that side. And this denominator cancels with him, and I'm left with just this on this side. So it would be good practice for you to pause right now and go ahead and try to solve the equation on your own and then pick back up. So I hope that you notice this is a quadratic equation because I have an exponent of 2, which is the highest one. I'm going to take these two terms to the other side because when you have anything higher than linear, quadratic, cubic, quartic, you have to set it equal to 0 to solve. So when I bring that over, I have x squared. 2x minus x is still a positive x. Negative 3 plus 1 is negative 2. And then I'm going to try to factor it because that, of course, is the easiest way to factor our quadratics. And that leaves me with x and x, 2 and 1, and I need a positive x, so it's going to be plus 2 minus 1. And that brings me down to x equals, you set each factor equal to 0 and then solve it. So x is going to be negative 2 or positive 1. And I'm going to go back up and check and remember, what are my restrictions? X cannot be negative 2 So I'm just going to write down what we just did as we checked. And since x cannot be negative 2, then our answer is just x equals 1. Now, if you have time and want to, absolutely go put 1 in there and you'll find out that it does check. But that's another way you can know when you do your quiz or test whether or not you have the right answer before you turn your paper in. Okay, let's look at the next one. It's not a proportion because I have this plus sign in here, but I'm still going to multiply by the LCD to get rid of my fractions. And so remember, when I do that, I have to multiply it by the first term, and then the second term, and then this term on the other side. Okay? So when I do by this first term, my x plus 1 cancels, leaving me with x plus 4 times x. Or you write that in, doesn't matter. Then when I multiply it by the second term, oh, I have that plus sign, excuse me. Multiply by the second term, x plus 4 cancels, leaving me with x plus 1 times 3. And then on the last one again, the x plus 4 cancels, leaving me with x plus 3 times x plus 1. Now the order that I wrote any of these doesn't matter because 2 times 3 is the same as 3 times 2, so that order doesn't matter. But from this point, I cannot do anything but remove the parentheses. And so that's going to give me x squared plus 4x plus 3x plus 3 equals x squared. And some people are good. They're like going to go ahead and say, well, that's 3x and that's 1x, so that's plus 4x. And then the last term is plus 3. Okay, so this gave me these two terms. This gave me these two terms, and I FOILed and got that. So when I'm looking at that, we have squared, but I do notice that I have an x squared on both sides. So when I subtract it, that's going to fall out. I have a 3 on both sides. That's going to fall out. And then my students saw I had a 4x on both sides, so that's going to fall out. And so on the left side, all I have is 3x. And on the right side, when it all goes away by subtraction, I'm left with 0. And then I divide both sides by 3. And so x equals 0 divided by 3 is 0. Again, let's go look at our restrictions. X cannot equal, what makes that 0 is negative 1. And what makes this 0 is negative 4. And I didn't get either one of those. So my answer is x equals 0. Okay, moving along. Okay, our next one is a word problem because we don't want to forget how to do those. And distance problems are so familiar in Algebra 2, actually in lots of math. So sometimes the rational equations end up in our word problems. So we're going to practice both those concepts together here. You ride your bike to the store 4 miles away to pick up things for dinner. When there's no wind, you ride at 10 miles an hour. Today your trip to the store and back took 1 hour. What's the speed of the wind today? So I hope that it just popped in your head immediately that distance equals rate times time. That's something that you've, I know, talked about in a lot of math and science classes to this point. So we're going to use that formula to help us solve this problem. The next thing I do, what is the speed of the wind today? So this is what I'm asked for. So that's what I'm going to let my variable be equal to, and that's what I'm looking for. So I am riding to the store, and I'm riding back from the store. So whenever I do distance problems, I do set up this chart that my Algebra 2 teacher showed me, and it just really helps keep your information straight. So rate times time equals distance. So go back into my problem. You ride the bike to a store 4 miles away. So when I go to the store, it's 5 miles away. Well, that clearly means that it's 4 miles back from the store. When there is no wind, you ride at 10 miles an hour. So before you go and put in 10, remember there is a wind. Okay, we have a wind today. We don't know what that wind is. So what we're going to put is our rate is 10 plus the wind and 10 minus the wind. Now, it doesn't matter which one is which. The point of it is if you have a wind, at one way the wind is working with you and one way it's working against you. It will not matter. It just won't be the same both times. And when you fill in your charts, you generally want to fill in two of them from the information in the problem, and the last one you want to, the last column or last, yeah, that you're working on, you want to fill in from this relationship between rate, time, and distance. So if I know the rate and I know the distance, I hope you're telling me that the time is equal to the distance divided by the rate. So I'm just filling in this last one with math. Oh, and I wrote a 4 instead of a W. All right, so 4 over 10 plus W and 4 over 10 minus W. Today, your trip to the store and back took 1 hour. So I know if I add these two things together, they're going to equal 1. So that's going to be my equation that I'm going to set up. I'm going to have 4 over 10 plus W plus 4 over 10 minus W equals 1. And that gives me, so we're in a rational equation like we've just been talking about, and we want to get rid of those fractions. That's going to be the easiest way to solve it. So what is my LCD? That's not a fraction, so I don't have to worry about that term. But these two, the LCD is going to be 10 plus W times 10 minus W. And again, I got to multiply this by that, this by that. And if you draw the lines, then it helps you remember how many times things are going to cancel or what's going to happen. So my 10 plus W cancels. So he's gone, and that leaves me with 4 times 10 minus W plus this 10 minus W cancels because this is like over 1 if you need to. 10 minus W cancels, so I'm left with 4 times 10 plus W. And then 1 times anything is anything, so I'm going to multiply those two out, and that is going to be 100 minus W squared. So in case you forgot, y'all, this is like A plus B times A minus B, and that equals A squared minus B squared. And what you've been doing the last 2 days is going this way with it. So you can see that it's kind of important to be able to know how to go both ways on that expression. Okay, so let's get rid of our parentheses, and that leaves us with 40 minus 4W plus 40 plus 4W, and that's equal to 100 minus W squared. I got a minus 4W and a positive 4W on the same side of the equation, so that knocks out, leaving me with 80 equals 100 minus W squared. And if I take the W squared over there and the 80 over there, I'm going to get that W squared is equal to 20. And W equals plus or minus the square root of 20. And we have a word problem today, so we don't leave it as that radical. All right, so we're going to put that in our calculator, and when you put that in your calculator, you're going to get an answer, hopefully, of approximately 4.47 miles per hour. Okay, last problem. What are the solutions of the rational equation x plus 2 over 1 minus x equals 5? Now, use a graphing calculator. You can use one if you want to. You don't have to. You won't have one on the test, so, but if you want to check and know that you're doing the right things while you're doing your homework, I don't object to that at all, okay? And if you want to know how to use it to check your answers, then let me know and I will be glad to help you with that. So, x plus 2 over 1 minus 2x equals 5. The classes that I've taught so far have jumped to and said, let's multiply by the LCD, so that's what we're going to do. In my LCD, this is the only one I have, so it's going to be 1 minus 2x. And when I multiply, so I'm multiplying both sides of my equation by it, this goes away because it cancels, leaving me with x plus 2. And then 5 times 1 minus 2x is going to be 5 minus 10x. So I like a positive x, so I'm going to take the 10x over there and the 2 over here. So if I add 10x, x plus 10x is 11x. And I subtract 2, 5 minus 2 is 3. And then I divide both sides by 11. Okay? And before I do that, I'm going to check what my restrictions are. My restrictions are just 1 minus 2x cannot be 0. So if you add 2x, you will see that x cannot be 1/2. And that doesn't conflict with our answer that we have, so we have x equals 3/11. So that's our lesson. If you have any questions, please come see me or email me and I'll be happy to help. Have a great day.